The Indian Association of Structural Engineers, also known as IS-Struct-E, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. IS-Struct-E is registered under the Societies Registration Act 21 of 1860. IS-Struct-E is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, IS-Struct-E has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik, Shri Manoj Mittal and Professor R. Pradeep Kumar. As its president, IS-Struct-E is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, IS-Struct-E has collaboration with various international professional like-minded associations and institutions. IS-Struct-E's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. IS-Struct-E endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. IS-Struct-E is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs. Seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. IS-Struct-E's activities are widely appreciated and known for quality technical contents. IS-Struct-E is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines, and a monthly newsletter. IS-Struct-E's publications are becoming popular with time. IS-Struct-E has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, IS-Struct-E started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. IS-Struct-E is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. IS-Struct-E has its student chapters in several leading engineering institutions as well. Membership of IS-Struct-E is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IS-Struct-E is available on its website www.isstruct-e.co.in.
So, Vikas? Good
Yes.
afternoon. Good afternoon, and I welcome all the participants who are attending this webinar. Today's topic is advancements in geotechnical engineering, innovative technologies, and solutions for enhanced foundation performance. As you know, geotechnical engineering has a very wide applications, not only for buildings, but it's widely applied to bridges, tall structures, cooling towers, and chimneys, highway design, embankment design, slope stability, hill cutting, tunnels. I mean, it's such a vast field. And geotechnical engineering, depends upon the data which we collect from the site. Unfortunately, in our country, we are using very sophisticated softwares, whether it's a structural design or for geotechnical design. But the geotechnical design depends upon the reliability of the data which we collect from site. Unfortunately, our geotechnical investigation has not kept pace with the sophistication which we have in design. So that's a very sad story, and it is taken very casually. It is not done properly. There are many reasons for that. Now, with the result, either you under design the structure or you over design the structure. Either the structure will be unsafe if it is not done properly. For example, the strata you may assume as a sandy, and if it is a clay, there may be long-term settlements which you don't even know about, and you will realize only after a few years. So the importance of geotechnical engineering as well as investigation has to be understood by all the designers, particularly the structural designers. Today, okay, so far our investigation generally is limited to SPT test. We do some SPT test, collect some so-called undisturbed sample, and do the lab testing. Most of the designs are based on the lab testing. Now, lab testing are done on a highly undisturbed samples. The results are very conservative, and our geotechnical fraternity also report very conservative results. So we have a low bearing capacity, we have a low pile capacity. Everybody wants to play safe, but in that process, we are consuming our natural resources, and we don't care about the sustainability, though we talk about it. We don't care about the carbon footprints. The mindset is the structure should be as heavy as possible so that it doesn't collapse. And it comes out of ignorance. Basically, the reason is ignorance. So today, Mr. Saurabh Gupta will guide us about the advancement in geotechnical investigation, and he will tell us what are the tools and techniques available for doing a proper geotechnical investigation, which may be slightly costlier, but may be more reliable, and maybe engineers develop much more confidence in giving the design. So before I hand over the podium to Mr. Saurabh Gupta, I would like to introduce Mr. Sandeep Patiwar. Mr. Sandeep Patiwar is a director in Tech Tangent Solution Private Limited, has more than 30 years of experience in structural design, mainly bridges, metros, flyover, jetties, and other kind of structure. He worked in Gammon India Limited for a very long time, for almost 16 years. And after he left Gammon India Limited, he set up his own consultancy firm based in Bombay. He is a very active governing council member of IS Takti. He is also chairman of Professional Development and Technical Events Committee. He is member of many professional organizations and a very keen learner and very passionate about his job. So I welcome Sandeep Patiwar.
Thank you.
And then let me introduce our today's speaker, Mr. Saurabh Gupta. He is director of Sanjers Geotechnica Private Limited. Now we all know Sanjay Geotechnica Private Limited for a very long time. We know Mr. Sanjay Gupta, Dr. Ravi Sundaram, who are the founders of this company, and everybody knows about this company. It's a leading geotechnical investigation and consultancy firm in India. Mr. Gupta holds a BTech degree from the Indian Institute of Technology in New Delhi, and also Masters in Geotechnical Engineering from Stanford University, California. He began his career with Fugro West in California, focusing on seismic hazard assessment for international projects. In 2007, he returned to India to join Sanjers as a second-generation entrepreneur with a vision to transform the geotechnical engineering industry. So henceforth, he is a torchbearer of Sanjers Geotechnica Private Limited, and he has some modern ideas. And I wish that we all know from his experience, learn from his experience. With over 20 years of experience, Mr. Gupta is actively involved in professional bodies such as DFI, IGS, ISS, MGE, and the Bureau of Indian Standard. He is also a member of many committees, and he has published more than 34 technical papers based on practical fieldwork. So we have a real expert with us, well educated, well experienced, and with some modern thinking and modern ideas. So now we request Mr. Saurabh Gupta to make his presentation. Mr. Saurabh Gupta, please.
Thank you so much, Ahuja Saab. I think that was a perfect introduction to the presentation itself. Uh, I want to thank Patwar Saab, Ahuja Saab, Mr. Bhaumik, as well as the entire IAS Shakti community for giving us this opportunity to share our experiences and ideas. I hope to take around an hour to go through the deck, and after which we hopefully will have time for some good question and answers and some interaction. Ahuja Saab, please confirm you can see my screen all right and hear me all right.
Yes, we can see your screen.
Thank you so much. So I'll get started. I think the question is, as Ahuja Saab said, कि हम लोग investigation कराते हैं, but quality of investigations is always a problem, and that is a national problem which needs to be addressed. So the question is, why should we invest in good geotechnics? तो ये पहला question है. Let's think about it. Foundations is the largest variable cost and risk factor of our projects. Typical foundation cost is around 10 to 15% of the project cost, right? So everything else remains the same. Your structural cost and timelines more or less can be predicted. The variability is always in the subsurface. And if you look at our project experiences, typically you'll find that this is where the play is. Now, what determines the foundation cost is definitely it's a geotechnical investigations, a geotechnical design for that project. But how much do we invest in the investigations? The ideal standard worldwide is, the ideal investment in investigation should be around 2 to 3% of the project cost. In Indian scenario, we are spending not more than 0.1 or 0.2% of the project cost in investigation. So the first issue is we are simply our focus and our money is not where our mouth is. As a result, we have several issues, and let's look at these issues. I think it's very rare that Indian projects are completed on time and on budget. The usual scenario is, that time and cost overruns in our projects. There is foundation distress or settlement, and sometimes there is catastrophic failure, which comes into the newspapers. We look at it and we forget after 2 or 3 days. This is a study by the government of India, which actually established they had studied some national highways, and they found that 50% of the project delays are basically because of suboptimal feasibility and investigation reports, right? And many such studies are available. I haven't compiled all of them. There are many such studies available, which actually, and I think our own experience also tells us that this is certainly the case with our projects. This is a common example when we talk about foundation distress, the Leaning Tower of Pisa. This is probably the most famous geotechnical failure or failure of geotechnical design that we are all familiar with, where the geotech engineers who were designing the Pisa tower, they inaccurately assessed the compressibility of the soft clays beneath. And as Ahuja rightly said in his introduction, the effect of this is felt long term. And then later on, you have to, nowadays, there's a lot of money. I don't know if you are aware, there's a lot of money and investment being pumped in to try to stop the tower from leaning further and from basically toppling over. Sometimes you have catastrophic failure. This is a picture of failure in China where the building simply toppled in. Later on, they found that the piles in this building were too short and did not take the loads. There's a nice line from Professor Littlejohn which says that you pay for site investigations whether you do it or you don't. This is another interesting study which shows on the y-axis your total increase in construction or your cost overrun in your project cost. And on the x-axis, you have the cost of site investigation as a percentage of project cost. Now, as we said earlier, this is where we are in India. We are spending not more than 0.1 to 0.2% of the project cost. And resultantly, if you look at the best fit curve, resultantly, our cost and time overruns are to the order of 50 to 100%. This is where we ought to be, ideally, is if we invest in proper investigations, proper ground characterization, then definitely we can reduce, we can plan our projects better, we can design our projects better, and we can control the overruns in time and cost of the projects. The Indian scenario is, unfortunately, even today, so many years after independence, the Indian scenario is not where we would all like it to be. Starting with, there's very little legal liability. So in case there is a geotechnical failure, usually, the owner ends up taking all the risk, and the risk is not disputed amongst the design community or amongst the contractors as effectively as it should be. The second issue is that the standards, even though BIS has been doing a fantastic job of trying to upgrade our old standards, but even today, a lot of our standards, codes, and project specifications are outdated. And we are still dealing with obsolete technology, which has been, forgotten worldwide. And in India, we are still using a lot of obsolete technology. We are still swearing by our plate load tests, our standard boreholes, and so on and so forth. And I think awareness has become a problem. We are not aware of good geotechnics. We are not aware of what is happening in the world around us. And those best practices are very slow in coming into the country. The other issue is there are very few good geotechnical investigation companies. And I think this is, our own estimate is less than 1%. A lot of companies are there, fly-by-night operators who are giving inauthentic data and inauthentic.
Mr. Saurabh, I'm sorry to
Sorry,
interrupt you.
please.
Actually, your face is visible on the left-hand side corner, which is occupying a lot of screen space.
Oh, okay.
So I'm getting, feedback that people are not able to read the
Got it.
entire
Yeah,
this
I
thing.
was also having a problem. Let me
Mhm.
share this again, sir, and see if I can solve for this. 1 second. So, is that better or
No, it
same?
is
No, it is still
no,
there.
no,
There.
it
So
is
can
still
someone guide me on how to solve this? I don't know.
Vikas, you are there.
Yes, sir, I am there, but I am not also aware
Or
of
maybe
that.
you
How
can
to remove. Just
reshare
wait.
your PPT. I mean,
मैं
Yeah,
अपना
yeah.
वीडियो या तो बंद ही
Yeah,
कर
sir.
देता
Maybe,
हूँ,
maybe you can stop
right?
your video. Then
you
maybe
can
your
stop your
images.
video. No, but let us see if you can stop your video.
All right, let's do that. How's that?
No, the logo is coming.
Your logo is still coming.
Yeah. Maybe
I
there is a
stop my
setting
video.
about.
Or maybe you can reshare it. You told me you are sharing through Google, but maybe separately you can share it.
Technology. Okay, hold on. I think I can get it. Is that better?
Yes.
Yeah, clear now. Yes.
Chalo, sir. Engineers, we can solve anything if you want to.
It's
Chalo,
good.
thank you so much for pointing it out, sir.
Thank you.
Okay. Sorry. So let's continue. I think we were talking about low
Before Mr.
awareness.
Saurabh, one more thing I
Yes.
want to tell the audience. All the questions will be put in the question answer box, not in the chat box, because in the end we would like to answer those questions. So I request all the participants to put in the question answer box. Yes, Mr. Gupta, please proceed.
Thank you. Thank you. So we were talking about, and this is, I think, so a lot of structural engineering friends of mine have also expressed this, and I think you would all know this from first-hand experience. A lot of the soil reports which you get, the data itself is unreliable or untrustworthy, and that really, I think, we feel sad because it really pulls down the fraternity, and it makes, I think, even the job of the structural engineer very difficult, right? The other issue is that in India we don't have a culture of having full case geotechnical design companies. So internationally, you have companies like Langen, Golder, which are geotechnical design companies. In India, usually we don't have that. We have a few independent consultants. We have investigation companies, and the rest of the work, sometimes, the structural consultant takes care, sometimes the contractor takes care. Of course, the L1 procurement practice is hurting you and me both. And this is something which is destroying, I think, the entire ecosystem of consultancy and design. And the result of all these practices is, there are time and cost overruns on our projects. There's conservative design, which is essentially the same as leaving money on the table. And there's poor construction practices, leading to delays, lawsuits, so on and so forth. So that's the Indian scenario. So we have established, I hope, why we need good geotechnics is basically to counter all these problems and to improve the state of industry in our country, improve the way we deliver our projects for our customers. I want to get into what is good geotechnics. It's very simple, and we always go back to the simple analogy. जैसे blood test होता है, investigation is like, getting a diagnostic medical test. The purpose of investigation is to give you reliable geotechnical parameters and reliable data. Now, there are two ways of doing it. Depends on the level of reliability that or confidence you're looking for. Simple एक होता है कि, if I go somewhere, somebody just does a few basic tests, does some blood tests and blood pressure and gives me an analysis. That is similar to a conventional investigation, right? It's something which is easily available. It's something which might be a little cheap or might be, we might be comfortable with it. But as we move up the value chain, if there is a risk to me for my health, I usually like to go for data-driven decisions. I usually like to go for advanced testing. Same way, if it is my project, then I would like to go with advanced geotechnical investigations. So I get some accurate data for data-driven decisions, not field-based engineering, but data-driven engineering. So we sat down and we defined levels of geotechnical input. We said, boss, you can have bronze, silver, gold, or platinum level investigations. And we always tell our customers that in the end, you will get what you pay for. Now, what is these levels? I will not go through this entire table. I think we'll be sharing, hopefully, the copy of this presentation with all the participants. If I have a very simple project, say I'm building a G+1, G+2 building in an area where, I have good experience, the geology is fairly good and competent, there is no harm in just going with a simple, empirical based investigation. You do a few boreholes, you do some simple testing. Your design might be a little conservative. You might be over designing your foundations, but it's not a very big problem for such circumstances. However, I think most of us these days, we are dealing with structures which don't fall under this purview. These days in India, as the country grows, we are building bigger. We are always, pehle we used to talk about G+8, G+10. Nowadays, nobody talks less than 40 stories, 50 stories. So as your structural demand increases, and also as the ground conditions, because now good ground is not available anymore. We are now building these days in Kutch, Mundra, in areas with soft ground, liquefaction ground. So as the ground conditions become more complex and also as the structural demand increases, we need to move up the value chain and go up to gold level investigations. And that is what we are talking about today, right? In gold level investigations, we are talking about doing advanced technologies, doing advanced investigations, proper ground characterization, followed by detailed analysis and data-driven decisions. And what we have found is, sure, your investment in investigations might increase somewhat, but your risk, your ground risk will reduce substantially. And that is what we find. So there are studies in Australia which find that as you move up the value chain from bronze to silver to gold to platinum, your strength reduction factors improve, your foundation cost reduces, and also your foundation construction time can substantially reduce based on the level of geotechnical input that you have for your project. There are many areas of improvement. If I go back to the Indian scenario, of course, awareness being one of them, and the sessions like this will hopefully go a long way in building awareness within our communities and between our communities, both. The GE selection process, we have to move away from L1 based procurement. We have to educate our clients not to select design consultants like you and us based on just L1 criteria, but to select us based on our technical competence and based on what we are offering to the project. Data reliability, we will be talking more about this, and we have been talking about this, that if you don't have data reliability, it's garbage in, garbage out. So no matter what fancy software you use, whether you're using Plaxis or SAFE or STAD, if your geotechnical inputs are incorrect, everything else is down the drain. Defining the soil investigation scope, this is very important. Very often we find copy paste inquiries, irrespective जो एक जगह project बनाया, we have a scope. The same scope cannot be copy pasted for the next project. Your structural might be different. Your ground conditions are likely to be very different. Your geotechnical challenges and risk is going to be very different. So we always talk about customizing your scope of investigation. And this is where we need to put in a maximum time and effort and thought, is customizing the scope of investigation on a project-wise basis and tailor making that scope so that all the future geotechnical risks are predicted and are taken care of in the GI report and in the GI program. Selection of tools, we will talk about this. Geotechnical reports, of course, need to be improved and standardized, and there should be a certain minimum benchmark for geotechnical reports that we should expect and we should demand from our customers as well. The GE-SE interface is always important. I think we talk about soil structure interaction, but interaction between you and us, I think, becomes very critical for projects. The role of the geotech engineer should not stop once the investigation report is submitted, and we should go on continuously communicating and working, going back and forth until we deliver the optimum design scheme for our customers. Last but not the least is construction monitoring. Whatever you and we do on paper has to be translated to the site. So I think, it's important that we get our hands dirty and we step out there, go to project sites, and we make sure there is a system and a QA/QC process in place so that, the on-paper design can be effectively translated to the site. Sorry. And this is where, we talk about a 360-degree solution. So again, to be clear, there are usually 3 touch points. And sometimes in projects, it's very unfortunate that the 3 touch points might be 3 different individuals or 3 different agencies. For our projects, we always, try to explain to our customer why it's important to have a single point of contact and single accountability for these 3 factors. The first is the investigation. The investigation agency, just like the diagnostic lab, their job is to give you reliable geotechnical parameters. That's all, right? The geotechnical consultant, of course, is may or may not be the same. Ideally, should be the same as the geotechnical investigation agency, but may not be. The geotechnical consultant's job is to predict the risk, the ground risk, design the scope of the investigation, and once the investigation data report comes in, is to interpret those parameters and then predict pile capacities or predict open foundation recommendations, do the retention system design, and so on and so forth. The third touch point is, now that the paperwork is done, as we said earlier, the third touch point is foundation QA/QC. It's very important to have the structural engineer and the geotech engineer both involved in vetting the drawings, in the instrumentation process, in the pile load tests, and so on and so forth. So that if you have, if these 3 things, they are like the 3 legs of a tripod. It's only if these 3 legs are strong together, that's the only way that your project actually has a reliable foundation to sit on. Then, of course, I'm not going to go through this. There's a flowchart which is given, which is very popular. I think this is from the Eurocode, where your risk-based flowchart for site characterization. As I said earlier, every project, you cannot have a copy-paste investigation. If you have a critical project, it makes sense to do a staged investigation. And that's what the BIS standard also recommends. You might do a pre-purchase investigation, which is a simple investigation just to figure out, what are the ground challenges at the site. You may follow up with a detailed investigation, which could be single or double phase. And then in the end, during construction, you may also want to do some confirmatory investigations to establish whether the ground conditions predicted are actually matching what you're getting in situ or not. So a staged construction process and all this planning and prediction should happen in the beginning of the project. It should be documented so that our projects follow a certain norm and we don't have any ground surprises during construction. Let's look at we mentioned technological advances, and I said earlier, I made a remark that in India, we are using obsolete technology. So let's look at what are some of the new advancements in India and globally that we can implement on our projects. Before I get into that, I want to talk about the so-called standard penetration test, the SPT. This has been around since a long time. It's been about 100 years, and a lot of us swear by the SPT values. Few of us, I think, may not be aware that there is nothing standard about the standard penetration test. It's a very good test, but it's a very limited test in the sense that it's a very simple measurement of the soil behavior. You take essentially in an SPT test, you take a hammer of a certain weight, 63.5 kgs, you drop it by a specified height. The number of blows required for a set penetration of the split spoon sampler is the N value. Simple as that. But did we know that the SPTN value actually depends on all these parameters? It depends on the drilling and the borehole technique. It depends on the equipment being used, on the test procedures, on the energy delivered, on the overburden stress, and the ground conditions. So with all these factors affecting the SPT, the chances of getting, the correct or consistent SPT values at the site are very low if we don't understand how the test is to be done right. One of the important things, of course, the first step is that the hammer itself should be calibrated and the weight should be accurate. This is the first step. The second step is if you are measuring number of blows or number of times the hammer falls down from a specified height, that specified height must be fixed. A very simple thing, and this is now there in our code also in 1892, a very simple thing which we can give in all our specifications is we must always, our specifications must always have the use of an automatic trip system, which is like this, right? Automatic trip system, very simple mechanism, hardly cost anything extra and very common in the industry. All that this does is that it ensures that the height of fall of the hammer is going to be consistent. The next value addition is the SPT energy measurement. Now, if you look at bowls or you look at any other book for geotechnical, usually all the N value correlations and all our parameters, E value and bearing pressure is all based on N values. They're all based on empirical correlations. Most of the empirical correlations are based on N60. What does 60 stand for? N60 means that it is assumed that the potential energy of the 60% of the potential energy of the hammer will be transferred to the ground while carrying out SPT. But do we ever know what is the actual percentage or the actual energy efficiency of the SPT system? We don't. And we've never bothered to test it also. So lately, it has become very common on many projects, including the high-speed project and other projects. It's becoming common to measure the energy transfer ratio. So there's an equipment like this, which is called an SPT analyzer. It's very simple equipment. It's got accelerometers and strain transducers built in. You put this equipment here in line with the SPT arrangement. And when you do, when you take the machine on site, you can actually go, it's like a calibration of sort. You can actually go, you can fix this equipment to your SPT system, and you can measure on site what is my energy transfer ratio. Right? Now, your energy transfer ratio, which is called the ETR value, that divided by 60, is the correction which you can apply on your field N values. So in this case, if you see the graph on the right, the red line is the measured SPT N value, which was given in the field bore log. When we correct for the energy efficiency, we get the blue line. So you can see that there can be substantial change in the SPT N values, and resultantly, obviously, all our downstream calculations and analysis will also change proportionately. To give you a case in point, Supposing I measure an SPTN value of 10 on the site, and I give, based on that, I recommend a bearing pressure of 100 kPa. Right? Now, if I do the energy measurement for our automatic trip hammer, we have measured like now we have carried out hundreds of measurements on our sites, on other people's sites, different kinds of rigs. What we find is that the hammer efficiency will vary anything from around 25% to 85%. Huge variation is there, depending on different equipment, non-standard equipment being used in different parts of the country. If you use a Sharon auger drilling rig with an automatic trip system, typically the hammer efficiency is around 75 to 80%, which means that my value of 10 gets corrected to 13. If my N value gets corrected from 10 to 13, my bearing pressure, which is calculated, changes from 100 kPa to 150 kPa. Right? Now, this is huge change in the SBC value, just with the introduction of a simple calibration measure, which is very trivial and hardly costs anything. On the other hand, if my SPT system used at site is an inefficient system and the hammer energy might be 40%, that means the measured value of 10, basis which I had given originally a 100 kPa value, is actually unconservative. The actual field end value corrected is only 7, and the actual SBC value should only be 75 kPa. Now, in this case, remember, when we give these bearing pressure values, there is no safety factor here. This is based on settlement criterion. So we are completely off, and these kind of foundations might be unsafe. So this is, I touched upon SPT. I will touch upon rock as well. In many parts of the country, in Deccan Trap area and other places, your bearing formation is not soil. It could be rock. It could be, bedrock. In rock, usually the analysis, the SBC analysis is based on, simply put, it is based on the quality of rock, the nature of rock, as well as the level of jointing in the rock formation. So the SBC of foundations bearing on rock is determined by the core recovery and the rock quality designation which we get when we drill through the rock. So if you drill through the rock formation, the rock mass, obviously in situ, the rock mass will be fractured and jointed, and you extract the cores from your drilling system. And that, when you analyze those cores, then you calculate the core recovery, and based on that, you give the bearing capacity value. This is a case in point where, simplified rigs, calyx machines with single tube core barrel were used on a project. And when we went back, and we always emphasize the use of hydraulic core drilling machines with triple tube core barrel, when we went back, we got at the same locations we carried out a confirmatory investigation. You see how the core recovery values and the RQD values changed drastically. And this simple, knowledge, or this simple practice helped the client save, almost 2 crore of rupees only in his foundation material cost. So huge difference. Just the only thing is knowledge. We always say that investigation is not only about boreholes. There's a lot of, although we are comfortable, it is commonly available. But borehole investigations, we have to realize, does have its limitation, and a lot of the interpretation is based on judgment. When we talk about selection of tools, actually speaking, and this is a slide from Professor Main, the Geotechnical Investigation Company theoretically has all these tools at their disposal. But हम लोग use सिर्फ SPT करते हैं. Right? I always feel it's like giving a hammer to a surgeon and asking him to carry out a complicated surgery. It simply won't go through very well. So we have to know, each of these tools will have their own pros and cons. We have to know, or the Geotech Investigation Company has to know, which tool to use under what situation. One of these tools, which I want to introduce to you, which some of you might be familiar with, is an electric cone penetration test with pore pressure measurement. The acronym for this is CPTU. It's a cone penetration test. Let's see what a cone penetration test is. This is the piezo cone, or the cone which is used. This is a fully instrumented cone. It's got load sensors and load transducers at the tip to measure the cone resistance, along the sleeve to measure the sleeve friction. It's got depth sensors, inclination sensors. It also has pore pressure sensors. So this kind of a cone is taken, and it is directly, see, there is no borehole here. this cone can be taken and it can be directly pushed into the ground using a hydraulic jack system. It is directly pushed into the ground, and as you push it into the ground, there's a laptop attached to the equipment. It will measure the ground resistance as the cone is being pushed into the ground, not only along the tip of the cone, but also along the sleeve. Plus, if it's a piezo cone, it will also tell you what is the pore pressure in the soil surrounding the cone as you push the cone. Now, let us understand. Uh, First, I want to mention that the CPT, or the cone penetration test, this is now there in the Indian code. I'm very happy to report 2021, the piezo cone found its way into the BIS standard, IS 1892-2021. We are also working, and I'm also in the committee, we are working on a standalone code, which will be IS 4968 Part 4. We have also drafted a new standalone code, which has been submitted to BIS. Hopefully soon, the code will be sent out into draft, into wide circulation, and then hopefully it will get adopted. This is the CPT equipment. It's quite straightforward. There is a pushing unit. It could be a crawler mounted, trailer mounted, truck mounted system. It doesn't matter. But there's usually a pushing unit. There is a series of push rods with cables going through them. And this is the cone at the bottom. And the cone is directly with hydraulic jacks. The cone is just pushed into the ground. These are some of the equipment which we are using. We have now, I think, 5 CPT rigs, and we are very busy running them on various kinds of projects across the country. And these are lightweight rigs which can be used to push the cone fairly effectively. Let's look at the limitation of the test. I think apart from capital investment and the knowledge and comfort, possibly the only practical limitation of this test is that it cannot be used in rock or in bouldery formation, right? Because the cone will simply go and if it gets into rocky formation, it will stop there. So, which is why I said that we have to know, the ground that we are going to investigate before we plan the investigation scope. So if we have in North India, in entire Indo-Gangetic alluvium, on the coastal areas and all that, CPT is a fantastic test. If you are working in Maharashtra, MP, these areas where rock is at shallow depth, CPT is not a good or an advisable tool for you. In places where we can use CPT, right? And I'm sitting in Delhi. In most of North India, CPT is very popular now. Let's look at why CPT is good. I like to say it's cheaper, faster, better. But let's see how much. So it's very fast. I can do a 30-meter sounding in just about 30 minutes. I get continuous data. Digital data is very accurate, very versatile. Typically, in terms of depth, we are able to push down to 30 or 40 meters in alluvium very easily. We have done some projects in Kochi where we managed to push down to 70, 80 meters as well. So in terms of depth, also CPT is very proficient. It's very reliable test. We can do sampling with the CPT, and I'll show you a slide for that. It's safe, clean, and it's cost effective. So let's look at some of these things, starting with pore pressure measurement. So remember, in a piezo cone, we have measurement of the pore pressures or excess pore pressures around the cone. So knowledge of that helps me in 2 ways. Number one, when I push the cone in sandy formations, the excess pore pressure will basically become equal to the hydrostatic pressure. And that information will help me determine quite accurately what is my depth of water table. Right? And that's usually a problem in borehole investigations, because borehole investigations, we do a bore, and then when we finish the borehole, we simply measure the water table, the stabilized water table in the bore. Sometimes the data might be inaccurate because of perched water table, because of water use in drilling, and so on and so forth. So I like the CBT because I get a fairly accurate measurement of the hydrostatic conditions. I talked about fast. Let's see how fast. One borehole to 30 meters. It involves rig shifting, drilling, testing, sampling. Samples are transported to the lab. You need 7 to 10 days in the lab, and then manual data compilation. So to get my report of one borehole is anything between 15 to 30 days. Compare that with a CPT where I can do the actual test in just 30 to 40 minutes. The data can be emailed to the office, put into a software, and I get a report in about 4 to 5 hours. So if my project has got 100 boreholes, my time goes down from, 8 to 10 months. My investigation time can go down to just 40 to 50 days. For highway projects, for large plotted developments, for warehouse projects and so on and so forth. This is, I think, a huge solve in terms of time. The other thing is it is very accurate. So in a borehole investigation, if you're just doing borehole investigation, you might miss a few thin seams or thin layers, which will later on become a problem. CPT investigation, your data resolution is just around the 1 centimeter. So even if there is a thin seam anywhere in your ground, you can catch it with a CPT and you can plan for it. Besides, it's very repeatable. So two boreholes done at the same location, you might have a standard deviation of 25 to 30% in your SPT values. Two CPTs done at the same location have got, it's published. It has a repeatability of 0.1% of the full scale output. It is company independent, operator independent, and always, with this kind of reliability, it really increases the designer confidence in use of the data for analysis. Plus, from CPT, you can also get your soil behavior type. And we have done now thousands of CPTs across the country. We've compared what we get from CPTs with what we get from boreholes, and the results are very heartening. Not only in India, but globally, there's since 1960s, there's a lot of data available. And the soil behavior type or the soil type matches fairly well. Since we measure the pore pressure, we can also stop the cone at any depth, and we can let the excess pore pressures dissipate. And that is something known as a dissipation test. A dissipation test is very useful because it gives me the in situ permeability and consolidation characteristics of the soil. So soft clays or clays, if I'm working in, usually if I want consolidation parameters, the SOP is to go do a borehole, collect a so-called undisturbed sample, transport the sample to a lab, and then we put it in an odometer. We wait for around 10 to 15 days, and we try to figure out the consolidation characteristics. With a CPT, with a piezo cone, you can actually just stop the test, and within a matter of 2 to 3 hours, you get continuous data in situ without any sample disturbance, and you get fantastic consolidation parameters. So you can predict your secondary settlement of your foundations as well with great degree of accuracy. Lastly, I think one of the big hesitation for CPT is, some people said that, we are not able to see physical samples and we are not used to it. So we also imported a lot of CPT samplers. So now with the CPT equipment, you can actually lower a CPT sampler. This is a fantastic push sampler. It gives very good quality, nearly intact samples, which can then be taken and they can be sent to the lab for some lab testing and for verification. This is what a CPT report looks like. You have your cone tip resistance, you have a friction ratio, you have a pore pressure. Notice how the pore pressure line matches the hydrostatic line perfectly in sands. And then you get your soil type. What the CPT also gives you is it gives you all these geotechnical parameters, including the equivalent N60 value. We have done this because, see, SPT, we are so comfortable with SPT. We have done hundreds of cross correlations where we have compared SPT values measured from a borehole and SPT values interpreted from nearby CPTs, and the values match perfectly well. All these parameters, constraint modelers, shear strength, undrained shear strength ratio, OCR, shear wave velocity, state parameters, so on and so forth. So all geotechnical parameters you get from a single CPT sounding and through the use of a software. You can also, if your site is liquefiable, and liquefaction is often a touchy subject, there are 3 ways to figure out what is the liquefaction potential or susceptibility potential at your site. You can do it based on SPT, based on CPT, or based on shear wave velocity. Of the 3, what international literature suggests is that liquefaction analysis based on CPT and shear wave velocity are far superior to what you can get based on N values. And one of the reasons for that is that SPT values themselves are not repeatable and can be fairly unreliable at sites. So CPT, I think in sites where we are suspecting liquefaction, we are really deploying CPTs to our advantage, and it gives us a lot of confidence in our seismic analysis. A quick comparison, just to summarize this, between our conventional approach of boreholes and CPTs. we see how CPT is much faster. It's around 5,000% faster as compared to boreholes. In terms of data resolution, I go from meters to centimeters or millimeters, so it's around 30,000% more continuous or more granular as compared to borehole data. I like the fact that the data is digital and hence it is not human dependent. So human errors are reduced. The data is very repeatable and you get far more measurements and interpreted geotechnical parameters from CPT as compared to boreholes. Last but not the least, in the introduction, Aujaz Saab said that advanced technology is always a little bit expensive. I'm afraid I beg to differ. If you do it right, advanced technology can actually be cheaper. So it turns out that carrying out a CPT test is actually can be the same cost or maybe even slightly cheaper as compared to carrying out boreholes. So there is no now if it is as long as the CPT test is applicable to your site, I think there is no issue because you're solving for time, you're solving for costs, and you're solving for quality, all three at the same time. So that's CPT. I want to point out here that I do not recommend replacing all the boreholes with CPT. Usually, if you're working in unfamiliar geology, it's a good idea to carry out a combination of various geotechnical tests. You may want to do boreholes and CPTs both at the site, cross-correlate the results so that you have two different approaches and you increase the reliability of your interpretation. The second thing I want to introduce to you is pressure meter tests. If you go to France, all their geotechnical design is based on pressure meters since the last 100 years. They don't look at anything else. And let's talk about why this is important. I'm going back to basics of geotechnical. When we give our so-called SBC value or the net allowable bearing pressure, you will recall basic geotechnics that your net allowable bearing pressure is the lower of what you get from your strength criterion and your settlement criterion. Now, most of our rafts for most of our large, tall buildings and all, they're not going to fail in shear. So the strength criteria, we are always talking about gamma C5, which determines your strength, your safe, bearing capacity. Now, this is where the factor of safety is, but really this is not important to us. So if we are doing, serviceability limit state analysis, if we are doing design of our structures, usually what is important is the settlement, that the settlement of the foundation should be equal to or less than the the prescribed maximum tolerable settlement for that structure. When we look at settlement, few things to remember. Number one is there is no safety factor in this analysis. It's a direct prediction. So corresponding to this load, this will be my settlement of the foundation. There is no safety factor. The other thing is that if I am idealizing my soil, which is obviously, we all know, heterogeneous and anisotropic and so on and so forth, if we idealize it as a linear elastic behavior, and it's an idealization, then the slope of that idealization or the stiffness or the modulus is basically what determines your net bearing pressure, is basically what determines your so-called K value. So the entire game, when we do geotechnical design, the entire focus has to be to get measure the ground modulus as well as possible. And that's where pressure meter comes into play, because while all the other tests, whether it's SPT or CPT or other tests, the modulus value is a derived value. It is based on empirical correlations from field data. The pressure meter is one such test where you actually go down into a borehole and you have a probe like this. The probe is expanded against the soil and you measure the pressure volume curve. By measuring the pressure versus volume behavior of the soil, it's kind of like doing a plate load test inside the ground horizontally, sort of. Right? When you actually measure the pressure versus volume behavior, the slope of the pressure volume graph gives you a very good measurement of the in situ horizontal deformation modulus profile. And this is golden for us. This is what you get. If I am using, if I'm getting my stiffness or my elastic modulus just from correlations, this is what we found is when we use n values and we use, say, Bowles correlation standard, we're all familiar, you get an elastic modulus profile like this, the blue line. You use a different correlation based on n values, you might get a slightly different profile like this one. But if you're doing in situ testing, so if you're doing CPTs, which is the blue line, or you're doing pressure meters and you're actually measuring the modulus in situ, which is the green triangles, you actually get a much better soil modulus profile or stiffness profile measured in situ. Right? And I want you to keep this in mind, because when we look at a case study, we will come back to this. I'm going to quickly move on to shear wave velocity. Just touching upon this, shear wave velocity is going to become very important in the times to come. I think you're all aware of the draft IS 1893, wherein the site class will now be based on the VS30, or the average shear wave velocity in the top 30 meters. So basically, for every project, no matter what, we will have to know what is the shear wave velocity profile. So we have to start getting comfortable with how this is measured. There are many ways to measure the shear wave velocity of the ground. And this is an important parameter for geotechnics, because the shear wave velocity is an intrinsic parameter of the ground. It doesn't change, right? So measuring shear wave velocity is in any case very useful for geotechnics. There are various ways to do it. There's surface methods, borehole methods, and lab methods. I want to talk about the two most common methods of measuring shear wave velocity. The first is the cross-hole seismic test. This is the gold standard for measuring shear wave velocities. It's fairly straightforward. You have a source borehole in which you put a hammer or a source. You have two receiver boreholes in which you put triaxial geophones. They're like receivers. So it's very simple. You impact the source, you generate elastic waves, the compression waves, relay waves, and also shear waves. And then you catch these waves in the receiver. Velocity is distance divided by time. And that gives me the compression wave velocity and the shear wave velocity. These are used to calculate my dynamic modulus of the ground and also my dynamic soil modulus. Very useful for design of machine foundations and for design of structures under dynamic or seismic loading. There's a second option now. Since if we are doing CPTs at the site, we can also replace a piezo cone with a seismic cone. Now, a seismic cone is essentially the same as a piezo cone, except it also has some geophones built into the cone itself. So what that means is I can actually I can do a regular CPT. I can stop the cone at various depths. I can impact at the ground, and I can catch the seismic waves at the cone level. Again, velocity is distance divided by time, and I get a fantastic shear wave velocity profile at that location. Why is this good for us? And again, the limitation of seismic CPT is same as CPT, is it doesn't work in rock. It only works in soft ground, in soil. So again, the comparison is, why sometimes we like to use seismic CPTs. It's a lot faster as compared to doing a crosshole. The crosshole test typically needs around 30 to 45 days because you have to carry out the boreholes, case the boreholes, grout it, do the test, process it. So in terms of, and the seismic CPT, you can get the results in about 4 to 5 hours. Second is it's a lot cheaper as compared to crosshole because you don't need boreholes for seismic CPT. And third is, you are actually getting at the same location, you get CPT values and shear wave velocity at the same location. So one test which gives you both the things. Lastly, I quickly want to point out that shear wave velocity measurement is not only for your site class. Shear wave velocity measurement is also very important from a geotechnical point of view because I get remember we talked about modulus being very important. So shear wave velocity measurements will also give me a very good idea of my modulus of elasticity at the site, and that can be used for static analysis of the foundations as well. This is where seismic CPT lies in terms of cost and time. You'll see that it's cheaper and it also takes a fraction of the time as compared to all other measurements of shear wave velocity. We said earlier that no matter what we do on paper, if my foundations don't perform at site, everything else is useless, right? So without getting too much detail about this, we are familiar with the static pile load test, which is a top-down static pile load test. We do encourage, if you are investing in a static pile load test, especially an initial test at your site, we do encourage customers to carry out an instrumented pile load test. So you, rather than just getting a yes, no answer, pile fail or pile pass, you can actually instrument the piles using strain transducers and telltales or extensometers, and you can actually get a lot more information about why, how the ground is performing vis-a-vis the pile, and if the pile fails or passes, what is the reason for it. It doesn't cost a whole lot extra. So for critical projects, if you're talking about gold level investigations and testing, instrumented pile load test is the way to go. These days, again, the bidirectional static pile load test has also become very popular, but I think that's a topic for another complete webinar by itself. Uh, One is the piles will fail because of one of two reasons. Either it's a geotechnical failure. We did not understand the ground situation well enough, or we underestimated it, or it's going to be a structural failure in the sense, especially in board piles, if the piles are not cast properly. So several methods are there. You have got the low strain pile integrity test, crossover sonic logging, thermal integrity test for figuring out, what is the structural integrity of the pile. Again, I always encourage that this should be done third party, all these tests, not by the piling contractor. So you actually get some, reliable test results. The other thing is the high strain dynamic load test. And this is not a replacement for, but it could be a very good addition to a static pile load test program. As compared to a static pile load test, a dynamic load test is a lot cheaper. It can be done in about 2 hours time. You can carry out the test, and it gives you a whole lot more information about the pile if done right and the ground as compared to a static top-down test. So a fantastic test if you don't have the time, you don't have the budget, or just to correlate to understand your static pile load test results. This is a quick slide. If you combine the two things, if you combine good geotechnical investigations with a good pile testing program, things start making sense. So this is from one of our recent forensic investigations where we did some CPTs, and we found, what missed in the boreholes. We found some loose strata between 18 to 20-meter depth across the site. Turned out it was an underground river of sorts. The piles had already been cast. Remember, this was forensic, and the piles were failing. So when we did pile integrity on the piles, we found that the piles were collapsing exactly at the level at which this loose formation was encountered. So look at the amount of useful information which you can get if you know what you're doing and you do the right thing. I'm going to, in the interest of time, take another 5 or 6 minutes, just take you through a case study so you understand, how some of these things are actually implemented in practice. I'm taking an example of a high-rise building project here in Gurgaon. Uh, I want to start by talking about the codal requirements. I think a lot of work has been done by us to upgrade our codes, and we are grateful for it. So the IS 16700 2023 and the 1892 2021. This is a quick summary of what the code says, and I think most of you would be aware of it, but I'll repeat. Uh, if you're talking about high-rise buildings of more than 50-meter height, you might be aware that as far as investigations are concerned, the Corps now mandates carrying out minimum 3 tests per tower. You have to investigate to at least 2 to 3 times the anticipated width of the foundation below the founding level. In the case of piles, of course, you have to go down below the anticipated pile tip level. And 1892, as we said earlier, also mandates the use of automatic trip hammer in place of regular drop hammers. Of course, if your structures become more complex, soil structure interactions such as Flaxus analysis and other methods are now part of the code. And in any case, I think it's good practice, especially if you're going for a pile draft system. Last but not the least is settlement and pressure monitoring. This is something which is very important. If we are moving up the value chain and if we are improving our design methods, improving our construction methods, one very important thing which we all need is feedback from the site. So we all learn from our projects and we improve as a nation. So settlement and pressure measurement is mandatory as per the code now, clause 11.3. And all of us have to work together to convince our clients to carry out actual settlement measurement of their foundations. So we get some real live data feedback, which we can use on our future projects. And this is how the nation will grow. So quickly back to our case study. This is a fairly simple project. Nowadays, a very commonplace. 5 high-end towers, 40 stories, and a few small towers as well. What we did is the client originally came to us with a standard BOQ for investigation. We spoke with the customer and we said, hey, instead of doing so many boreholes across the entire site and spending so much time and money, why don't you utilize this budget to do some smart geotechnics? So what we did is we did just one deep borehole, 60 meters per tower. We did two CPTs per tower. Uh, we also did some pressure meter profiles and we did some shear wave velocity testing. When we did this, and I'll cut to the chase, we did an analysis. Again, as I said, modulus is most important. So when we compared this was the orange line, this was the modulus profile which they got from their old soil report, which was based on boreholes. They already had a soil report, somebody else had done it, and they were not happy with the results. So this was the modulus profile which they got based on SPT. Based on our gold level investigations, the modulus profile which we recommended finally based on boreholes, CPTs, pressure meter, as well as based on shear wave velocity measurement was this. So typically around, it was substantially higher and we knew it. This is obvious. What this meant for the customer though was that if I looked at his strength criterion, the bearing capacity, we could go up from a value of 42, which was given in the old report, basic testing. We could recommend a value of 81 ton per square meter bearing capacity, 93% increase. If I could talk about the settlement criterion or the net bearing pressure, we went up from 29 ton per square meter, which was the standard value being used in the area based on boreholes. We could justify through data-driven analysis, we could actually justify a net bearing pressure of 65 ton per square meter, 124% increase in the bearing pressures. Pile capacities naturally also increased from 286 tons to 504 tons. I took the help of my very good friend and your colleague Ajay from Perceptive, and he helped me work out what does this mean for the client. We don't have these calculations. So the original SBC which the client had in the old reports was 34 ton per square meter. We gave an SBC of 77 ton per square meter for the same project, same location. So we did the calculation of the foundation cost saving, and I was amazed to find that the cost of the investigation was only around 45 lakhs. But the saving in the foundation material cost itself was more than 16 crores. So Ajay and I could go back to the client and we made this presentation and we said, boss, you are a money person. Let's talk numbers. In terms of money, your return on investment in investigation has been 3,600%, right? Not to mention the saving in your construction time, your risk mitigation, your reduced carbon footprint, reduction in overheads, and so on and so forth. So, and we have done this now. We have done more than 30 such gold level investigations for high-rise buildings all across, and we are finding these things consistently across all our projects. And really, in the end, what we have concluded for our customers is we say that good geotechnics is not an expense; it is an investment in your project. I see Ahuja Saab here back, so I'm going to quickly summarize. So we have talked about many things, and I hope some of these things made sense. One thing which we always emphasize is that geotechnical should not be field-based like Ayurveda. It should be data-based engineering, and we have to have good quality data. So we have proper engineering for our projects. It is important to invest in gold level geotechnics for critical projects. So we improve the safety and performance of foundations. Case studies have shown 50 to 150% increase in bearing pressures. We are not selling increase in SBC. We are selling reliability, right? But the value optimization is a byproduct of good engineering. Last is, I think all of us need to change our approach, starting with we should stop copy pasting geotech investigation scope. We must think about and discuss, every project and come up with the optimized scope of investigation and the optimized investigation program for our projects. And I think all of us have to get together to educate clients, why this is important. Better communication between you and me, soil structure interaction is very important. Gold level investigations, you get what you pay for. performance-based geotechnical design is very important. You have to design before you start making. Let's not jump and start excavating from day one. And last but not the least, third-party foundation QA/QC, proper instrumentation is very important. We cannot leave our projects to civil contractors appointed on L1 basis. Thank you so much.
Thank you, Mr. Saurabh, for your excellent presentation. Very informative and also very thought-provoking. You may unshare now.
Yes.
Unshare your answer. Thank you very much. I wish we had more
Thank you,
time
sir.
and we could have engaged you for a much longer time.
Thank you, sir.
Now,
I tried very hard to stay within the time given to me.
yeah, thank you very much. Thank you very much. And the biggest takeaway is that you have opened eyes of many professional engineers. As you know, for last 50, 60 years, most of us have been doing only SPD test. In fact, our codes also specify that. In bridge code, one borehole has to be done at every foundation location. It talks about only borehole. Forget about CPD. Even today, we have to mandatorily carry out a borehole with SPD test. And that's how the things have been going on. And you have highlighted many problems and many drawbacks, limitations of the SPD test. Even if we are aware of those things, still we are still carrying out that test. And doing a CPT test, it has really opened our eyes. And I wonder why we were not doing it earlier. And now also, how many people will, start doing it. But at least you have created an awareness among the professional fraternity that CPT test is one test which can give us so much of information, a lot of information, And now you have told us that it can even collect samples. Because if without collecting sample, if you do CPT, people may not be convinced, how do you classify the soil unless you see with your own eyes, whether it's a clay or sand. But if sampling can be done, nothing like that. I think it will totally replace the SPT test, maybe in due course. So wonderful. We are, and you, of course, you have told us a few more things. I mean, double tube versus triple tube core barrel, triple tube using core barrel. Even today, we are not using triple tube core barrel in most of the cases, maybe because of cost consideration. But I have seen the difference myself. It makes a big difference. And you told us a very important thing: deformation modulus. I mean, the increase in deformation modulus, tremendous. Of course, we will discuss a lot of things. I have a lot of things to discuss in mind. And before we go to question and answer session, there are some question and answer session. And a few of them are also in chat box. So we'll take one by one. So before we start question and answer session, I would request Mr. Sandeep Patiwar to express his views on this presentation.
No, yeah, certainly as you said, it was a very wonderful presentation. Because in fact, I think in the country, when the growth happens, there are a lot of importances required in the being a fast track project. Actually, see, when it was earlier, the competition was done in a different manner. Most of the calculation used to be done manually, whereas nowadays, advanced software, soil structure interaction, non-linearity of the soil, all those things are actually required when it is a structure performance is being seen, whether it is a wind performance analysis, whether it is a static analysis, or whether it is a dynamic analysis. And as Mr. Saurabh has said, it is costing a little bit more, but it gives a more accurate information, more accurate data, which has a confidence on both sides, whether to the user as well as the practicing engineer, and who can then limit the stretch of his design up to the ultimate. And it is neither underestimate nor it is overestimate, as exactly he said. So it is a balance requirement. Also, actually, there are so many surprises which has happened during the geotechnical. See, one investigation in one part, but when the structure actually is started constructing, and then it comes that there is so many a time structural surprises comes. So this can be certainly avoided by the correct geotechnical interpretation. CPT is absolutely actually many places in our project also we have done it in a Srinagar, and it is a wonderful tool actually. no doubt about it. And I think in many projects where, as he said, ki soil is predominantly there in a geotechnical part, CPT is a very nice tool which can give so much information. So thanks, Mr. Saurabh. It was a really very wonderful presentation.
Thank you so
Sandeep.
much, sir.
Thank you. Thank you very much. So now I would go to question answer session. And Mr. Saurabh, you can also open your question answer box. So let us start. Dr. Sushil Dhawan is a very passionate, he is our governing council member, very active member of
Yes.
he has active for a very long time. So I will
Yes.
just read out his question. Thank you, Dr. Sushil Dhawan. Role of geotechnical engineer and his association with structural engineer for getting the reliable results. Even basically, he's talking about interaction between geotechnical engineer and structural engineer. What are the findings from geotechnical engineer to design the structure? And these days we go for 2 to 3 basements in multi-story building in earthquake-prone regions and sandy, silty soils. So maybe he wants to ask what are the specific investigation to be done for such a case.
Very nice. Namaskar, Dr. Dhawan. Very nice to hear from you after a long time. I think I'll answer in part. I think when we talk about the role on a lot of our projects, I think a very good way of working which we have found, and I'm working closely with several reputed structural engineers in this way, is current system is client gives a requirement typically to the architect or the PMC or the structural consultant. And the structural consultant is forced to make a BOQ and a specification and give it to the customer. And customer then procurement people give it to the soil testing companies and get rates and award the work. So rather than doing that, if the structural consultant and the geotech consultant can get on board in touch in the beginning, and we can talk amongst ourselves and figure out, what are the anticipated geotechnical challenges. So see, even at our company, so what you're leveraging is we have a project database of 6,900 projects across the country. We have India's largest private subsurface database. So we are encouraging customers, consultants to email us, their project location, project details, and we are working out scope of investigation for stakeholders free of cost. So this is something we have started after COVID, and I think a lot of people have taken this up on us. We have a small team which is sitting, which only does this, and we don't charge anything for it. We don't expect inquiries to come in. So this is a simple solve. As I said, just at least we get the right scope of work defined for every project. So this is one. Then, of course, once we come on board, I think it's very important. What typically happens is that the report goes through and there is no discussion post that. There is no understanding of how the report is being interpreted, what is actually being constructed. Sometimes what is being constructed is totally different from what the soil report had assumed. And this is causing a lot of mess in the entire ecosystem. So what we always encourage is it should be part of the contract is regular discussions, meetings, vetting, site visits, QA/QC, and I think SC and G have to work very closely together for project success. And I know you feel it, I feel it, but I think we all have to work towards getting this actually implemented in the country, right? Um,
The
Second
last
is what are
question is
the
about basement. Yeah.
yes, please, sir.
Yes, please. No, I was just saying, I think maybe you have answered one of question number 1 or 2, maybe. What about third
Maybe.
question?
Third question, yes, I think 2 to 3 basements is very common. There's nothing to worry about. The only thing I'm worried about is design of the retention systems. So, I mean, very frankly speaking, when you look at a soil report, we have to ask the geotech consultant to give us appropriate parameters. Sometimes, with half knowledge, some of us will ask for C5 values without understanding that there is no such thing as a constant CN5 value of soil. There are 4 different kinds of C5 value for the same soil, depending on the drainage conditions and depending on rate of loading and so on and so forth. The soil is not steel, it is not, a fixed material. It's not a man-made material. The C and the 5 values, the strength behavior will vary drastically depending on what you're building and what are the loading conditions. So your C5 value for your raft will be different from your C5 value for your retention system. One might be undrained, the other might be drained values. Now, these simple understanding, is not built in, and sometimes we end up using the wrong parameters for design of retention systems. A lot of our retention systems, we have problems, with excessive deflections, with over conservatism, and contractors are making their money based on this. So, pressure meter, for example, is a very good test. I did not mention this when we talk about basement design. Pressure meter is a fantastic test to measure your K0 profile, and that should be an input to your design of the retention
You have
system.
lost your voice.
Really?
Yes.
No, it is
Now?
Okay.
there, sir. It is there.
Thank you.
Okay. Maybe
Yes.
problem is from
I
my
think
side.
that reply you can make it in the form of actually sensitivity with respect to the earthquake also. See, maybe I think they may be interested to know what will happen and exactly what to look for during the seismic condition or the dynamic condition, whether liquefaction and all those parameters are how to measure it, how to check
I
it.
understand, sir.
Yeah,
So
Mr. Chauhan has
liquefaction,
asked question. Liquefaction may also be discussed.
I have some personal views
Okay.
on liquefaction.
And
We've been dealing with liquefaction since Commonwealth Games and working very closely with IIT Delhi on liquefaction. One, I feel that sometimes liquefaction is a bit of a hawa. It's a little understood monster, and sometimes we treat it like that. कि liquefaction हो गया, hey Bhagwan. So I think, scientifically, liquefaction has got two parts. One is liquefaction susceptibility, right? And sometimes we start making a lot of shor sharaba about liquefaction, and customers start spending money on ground improvement and all kinds of things, without first properly investigating whether liquefaction actually exists or not. So as I mentioned somewhere down the way, so liquefaction susceptibility has to be if your site is even slightly susceptible to liquefaction, or there is potential for liquefaction. The first step is to carry out robust investigations to figure out whether or not liquefaction is even there. So you should carry out not just SPT again. You should correct your SPTs, get N60 profiles, get CPTs done, get shear wave velocity tests done. All these three methods will give you the cyclic resistance ratio, right? You may or may not also want to carry out a site-specific PSHA analysis to get your CSR value, which is a cyclic stress ratio value. A comparison of these two will give you a factor of safety for liquefaction. So the first step is robust investigations to figure out the possibility and the extent of liquefaction at all. Once this is established, only then we should go to solutions. Solutions can be several. One would be analytical, that you actually figure out liquefaction-induced settlements, and you try to predict that, and you incorporate that into your design. If that cannot be incorporated, then you can go for alternates, like ground improvement is very common. And then we can look at that on a project-wise basis. But it's not a panic button which should be pressed on a
No,
project.
I will tell you, Mr. Saurabh, it has created a
Yes,
lot of panic. The reason is
yes,
in our code IS 1893 and even in bridge codes also IRCSP 114, there is a
correct.
chapter on how to assess liquefaction potential. It depends
Yes,
upon N60 and other parameters and magnitude of the earthquake. Now, once we do that, we find especially Indo-Gangetic plain, in majority of the cases, we are finding liquefaction and to a
yes,
considerable depth. That's the problem because the procedure is prescribed. We have to follow that. Okay. Now in reverse, of course, there is a scour level, so liquefaction depth is generally above the scour level, doesn't create a problem. But what about the
yes,
approach roads, reinforced soil walls? Recently, I have come across many cases where reinforced soil wall we have a liquefaction. Okay,
yes,
if it's up to 2-3 meters, you can replace the soil. But if it's up to considerable depth, then ground improvement is required. I just
yes.
wonder that procedure given in IS 1893 that is creating panic. Whether that is correct or whether course needs to be modified, I don't know. But as of today,
I
you have to go by that.
the No, I have seen that, sir, and I'm familiar with this. The procedure given in the IS code is not new. It's based on the NCR summary report, which is very old. Yaud and Idris. A lot of people have done
Yes.
a lot of work in liquefaction. My own career started in California, so I worked very closely with Professor Seed and others on
Mm.
liquefaction. See, there are several factors. One, uh, the industry understanding and the research understanding of liquefaction is also changing day by day. So best practices on figuring out liquefaction susceptibility is also changing. And although the code gives us a starting point, it is not an ending point. We sometimes have to go beyond the code and look at best international practices and other publications as well. So this is my first point. Second is, what I am uncomfortable with is that a lot of us have seen the code. Some junior engineers sit down, takes the formula, makes a spreadsheet. We plug in some numbers into the spreadsheet, and then liquefaction ho gaya, करके we are jumping. And sorry, but I sometimes I feel that nobody is stopping to question the input parameters that we put in. So the input parameters for, say, if you're doing SPT-based analysis, input parameters SPTN values, finds content, right? But how many of us have stopped to see, again, this is the purport of my presentation, are the SPT values even correct? How was the SPT taken? Was energy measurement carried out? Was trip hammer used? मतलब वो 2 पैसा बचाने के बचा के हम लोग करोड़ों रुपया खर्चा कर रहे हैं sometimes. So this is where on sites like this, data reliability plays a very important role. Many times, cases have come to us where the client said, liquefaction, help us out, design a ground improvement scheme. We said, no, first we will check the ground data. We carried out confirmatory investigation and we found out liquefaction tha hi nahi. There was no problem to begin with. The third thing is choice of tools. So as I said, somewhere down the line, the Indian code as well as NCR summary report recommend liquefaction susceptibility analysis based on 3 methods: SPT, CPT, and shear wave velocity. If you look at recent papers by Idris and Boulanger from UC Davis, the preferred methods for determining liquefaction are based on CPT and shear wave velocity. Internationally, they're not looking at SPT-based method because of the unreliability of the SPT values themselves, and also the correlations based on SPT. But we are not carrying out, this minimum investment required to really take us forward. And directly, many people are jumping to liquefaction ho gaya and ground improvement kar lo. The third thing is, of course, ground improvement also, whether it is being actually done right, designed correctly, and implemented correctly. I have my doubts. Many times ground improvement is also money down the well. Nobody is checking ki actually is the ground actually improving or not. Ground improvement, if you spend so much money, the international again practice CPT is again very good for ground improvement. You do CPTs before and after ground improvement, and you actually measure whether or not ground improvement has actually taken place. But usually वो कोई कर नहीं रहा है. There's a contract given for ground improvement, and I don't know.
Yeah, thank you. I think our codes also have to be changed. Anyway, it's a long discussion, but thank you very much for your very useful information. Next question is casing necessary for borehole stability during sample retrieval of CPT?
No, typically not, sir. So the beauty of CPT is that we are not making a borehole. That's my first point. We are directly driving, so we have a cone and we are directly driving the cone into the ground. There is no borehole at all. And this is actually one of the good things, because when you make a borehole for sampling or for SPT, then the process of boring is actually disturbing the ground. Whereas if you're doing a push test like CPT, then you're actually simply pushing the cone into the ground. You don't have a borehole. And this is also the reason why the CPT samples, the push samples, are of very good quality. We are doing a project in Gujarat right now where we are doing extensive sampling with the CPT sampler, and we got some fantastic sample quality for some advanced lab testing. Much better than what I'll get with the Selby tubes in boreholes.
Okay. The next question is from Mr. Anup Kumar. How correct is ERT and BH parameters? Recently, ERT are gaining as an alternative to time-consuming boreholes.
Controversial. I don't, sir, agree with, principally speaking, as an engineer, I don't agree with, just doing one thing instead of the other. Even with CPTs, my recommendation was that we should be judicious. Maybe if it's a new geology, you do both the things and you cross-correlate. Now, a lot of people out there, and I've seen many presentations where people are selling geophysics as a replacement for geotechnical. Now, we also do geophysics in our company. So I've been doing ERT, we have been doing seismic refraction testing, all kinds of geophysical testing in-house, right? So we understand this. Now, geophysical is very useful. We have done it for metros also, but it's not a replacement for geotechnics. Both have got their own strengths and weaknesses. They could be complementing each other, but it should not be sold as a replacement. Right? You have to be very careful because simply doing geophysics, whether it's ERT, SRT, or whatever it is not, you can't rely on that for geotechnical design. I am not very comfortable with that.
Okay. Then next question is from Abel Kuriakos from SP Singla Constructions. His question is, what type of soil investigation is recommended for foundation resting on highly weathered rock strata, and which laboratory tests are essential to accurately estimate the bearing capacity and relevant geotechnical parameters? I think question should have been which test, whether it's a laboratory test or field test. So the concern is highly weathered fragmented rocky strata. What kind of soil investigation is recommended?
Got it. Perfect. So thank you for this question, sir. Incidentally, if you recall the slide which I showed you with, for rock drilling, so I emphasize that same way we have been talking about SPT, where if you have a site where you have particularly highly weathered rock formation as you do, the slide which I showed you where we talked about how if you adopt the right drilling equipment, so stop using Calyx machines, first of all. I think it's deadly. We should only use proper geotechnical drilling rigs like hydraulic core drilling rigs for drilling in such formation, number one. Number two, your tool which you use, single tube core barrel is not good for drilling in and for coring in such formation. You have to move on to triple tube core barrel. It's not a huge cost. And if you saw, by using the right rig and the right drilling tools, you can actually get the correct core recovery and RQD values and hence the right RMR values for design. And eventually, your design of foundations bearing on fractured rock is going to be based on these input parameters more than anything else. Of course, lab testing, you take intact soil sample, rock samples, you'll test for intact strength, modulus and strength and crushing strength and so on and so forth. But largely the design will be based on your core recovery values, which in turn is determined by your drilling mechanism used at site.
Okay.
The case study which I showed for single tube to triple tube was from a competitor of yours.
Yeah, so my question to you, see how much
Yes.
actually difference, suppose, because see many areas the rocky strata is not well defined in the sense that it is many places it is a IGM is there, whether it is not soil nor it is a rock, and it is very difficult time that core recovery comes very less. Sometimes RTD is zero and core recovery is maybe hardly 10%, 20%. Whereas suppose if we go with a triple core tube, then actually there is a significant improvement is there.
Yes.
So I think, see, again, it is a strata, again, it is a position, it is again depend on that rock, what kind of the soil, what kind of the rock geomaterial is there. And then it should be decided that whether it is blindly we cannot use, single core method tube can be used. That's very good.
Single core drilling, Saab, and Calyx machines, in my view, should be abolished. It's a strong view. It should be abolished. It's bad practice. As a very minimum, hydraulic drilling rigs with double tube. What we are doing on projects is we always give both items. We give double tube and triple tube. It's only a barrel is different, right?
Yeah.
The rate is not very different. Maybe 30-40% difference is there in the rate. So we always recommend that you go to site, you carry both the barrels. There's item for both. And in case you are getting, like you said, an IGM layer or even a fractured rock layer, then we resort to triple tube drilling, especially in the shallow depths, where your pile socket is likely to be, or where your maximum stresses are likely to be. We go with triple tube core barrel. As you go deeper, if the rock starts becoming less fractured or more intact, we go back to using double tube core barrel.
Very true.
But this kind of intelligent definition of the scope, that is very important because typically India mein kya, on projects what we are seeing is investigation ke time pe, we do something and we come up with a report which is indicating very, very poor ground. We over design the foundations. That's what happened in that Tapi River project. And then later on when the contractor comes, he also makes a claim to the owner saying ki, no sir, hard rock aa gaya, now I need more payment for excavation. So the owner gets hit both sides. What are we saving?
No, I think nowadays actually even client are the owner also, the contractor also who understand. Now they also started understanding the importance of such geo investigations where it is useful for them to decide the kind of the foundation or the type of the structure in future, or see if now it can be done based on that. And instead of going in a dark and where the lot of uncertainty is
Yes,
there, because most of the time, most of the uncertainty is always in a foundation, because see, top
correct.
structure and all those things is well defined. It can be done under control. But most unpredictable is thing a geomaterial. So
Honestly, Swab, इतना भी unpredictable नहीं है. I feel, मतलब
I
from
know,
our
but see,
standpoint.
I think, see,
eh,
still in India, we haven't divided a zones where this kind of soil and type of geomaterial is predicted, that could be actually very good, indicator. See
Yes.
what kind of investigation should be done from the initial stage, or what kind of things, somebody should prepare when he's making a proposal.
So, I honestly speaking, for critical projects,
Yeah.
we always recommend a three-pronged approach. The first step should be a desktop study. There's enough mapping and there's enough data available at a click of a button. आजकल तो ChatGPT भी है, to at least know what kind of geotechnical challenges we should anticipate. Very often for big project infra projects, what we do is we go always with a staged investigation. Desktop study. Phase one is a preliminary investigation. You go, you do two, three boreholes or whatever you want to do, or CPTs, just to figure out mota moti what is happening.
Yeah.
Right? Based on the result of phase one, then you should decide the detailed investigation program.
Yes.
Basic, you do it within the same mobilization. So this is very important. What we are doing is we directly jump into detailed investigation on a copy paste BOQ format. And once the soil report comes, then all the red flags are raised. कि liquefaction हो गया,
I think in
IGM आ
the
गया.
infrastructure nowadays, actually, when the DPR is prepared, they have a अपना certain investigations are done. So they have actually when अपना main contractor comes and then start work
Yes.
there, they have an idea that what kind of geomaterial is expected. So actually, he
Yes.
can plan what is the investigation to be done for his proposed structure, and economics can be certainly worked out.
Sir,
Correct, sir.
we
Correct.
have a lot of questions and we are running short of
Yes, sir.
time. So, Mr. Saurav, we have to quickly run through all these
Let's go
questions. There
through,
are a lot
sir.
of questions in
Yes.
chat. So that's what I said. I wish we had more time, but
I'm here all
okay,
night.
let's go quickly. Abel
Yes.
Kuriakos has asked another question. In weathered rocks data, where N values are consistently high with depth, I mean, he's talking of conducting SPT value in weathered rocks data. Is it still necessary to perform shear wave velocity investigations, such as the seismic crosshole test?
I get it. So
Alternatively, can the site class be determined by using VS30 based on N values?
yes. So answer is yes. Crosshole seismic is a very good idea. Either you do a crosshole seismic test or a downhole seismic test, which requires only one borehole. And so borehole geophysics is a very good idea. Recently, we did a project in Maharashtra where we had IGM material underlain by rock, right? And so we did a combination. We did MSW testing to get lateral extent of stratigraphy as well as shear wave velocities. And we also did downhole and crosshole seismic testing at few point locations to cross correlate all these three methods.
Okay.
And of course, then we did boreholes with triple tube and double tube core.
Okay,
So
thank you.
yes.
The next question is from Mr. Parveen Kumar. Can you please comment on the various advanced tests for estimation of grout consumption of soil layer before jet grouting? No, this question is unrelated.
Unrelated, but I think to really answer this, I think grout consumption is a function of the permeability of the ground.
Mhm.
So to really get good quality permeability values, if you're looking at soil or overburden, my recommendation is to do dissipation tests with CPT, which we talked about, right? The dissipation test will give you true radial in situ permeability values as opposed to, guesstimating those values based on textbook. So that will give you a very good idea of grout consumption.
Good. Then Mr. Akhilesh Kumar has asked a question. In case of socketed pile rock, in addition to vertical pile load test and lateral pile load test, is it required to do uplift capacity, or can it be derived from vertical pile load capacity? Okay, I mean, how do you
Interesting
test the
question.
vertical uplift capacity and whether
You
it can
can
be determined?
test. You can test. Of course, you can do a static pile load test for pullout as well. It's not very hard. The IS code also requires it. But typically, if pullout is not your governing criterion, which I think if you have a rock solid pile, typically it would not be for most structures, then I think many people eliminate the pullout test and they focus on the compression and lateral test in practice.
But sometimes it happens. There may be tension,
Yes.
maybe not in all the piles, one or two piles. It may come during seismic case. It may happen.
Yes. Well,
And then
if it's critical, then I think we should test for it. It would be dangerous to derive the pullout capacity from a vertical compression test, unless you have done an instrumented pile load test. If you have done an instrumented pile load test, you can actually segregate your skin friction contribution and your end bearing contribution, and you take the skin friction contribution for pullout. But if you haven't done that,
wholesale
then you
also
can't.
actually it can be done. Suppose in a wholesale, then lot of
Yeah.
instrumentation is done.
Yes.
Then you
Yes.
can find out what is the
Yes.
socket
Yes.
resistance and end bearing
Correct.
capacity.
Standard top-down static pile load test cannot be used. But if you've done an instrumented static pile load test, a high-strength dynamic pile load test, or an O-cell test, right? Then maybe you could theoretically calculate your pullout capacity.
this question is from Mr. Ramalingeshwara. There are scenarios where engineers referring shear wave velocity ranges mentioned in the code for heterogeneous granular backfill and trying to evaluate compaction. Isn't it misleading?
Yeah, I definitely feel it is misleading. I think compaction, I don't know how people are doing this. I haven't seen this. But really, I think you cannot evaluate compaction in this way. I don't understand. I agree with you, it is misleading. I don't understand the project case. Maybe if I understand better, I can.
Then Prashant Kumar has a long question in the context of Delhi infrastructure projects, especially with the increasing number of four-lane expansions across India. How do you see the role of geologists being systematically integrated into geotechnical investigation? Is there any established standard or guideline that mandates that their involvement at a particular project stage, say DPR, detailed design, or even construction? So
Yes.
that's the question.
I think it's a fantastic question, Prashantji. And I'm a geotechnical engineer, but I do understand the importance of geologists very, very, very closely, especially for such projects. And I think geology, geotechnical, and structural, again, is the tripod arrangement that we have to have for these projects. None of us can do it alone. So if you're working in hilly terrains, I think geologists are very important. Geological reconnaissance, geological studies must complement robust geotechnical investigation and a geophysical investigation. All these three have to be looked at together. None of these three things will give you the complete picture.
No, let us not see this question also doesn't seem to be correct. That is there any established standard or guideline that mandates their involvement? No, why mandate is required? If they are required, they are required. Like structural
They're
engineer, hydraulic engineer, or
Correct.
geotechnical engineer. Like if there's a requirement of geologists, they have to be engaged, like
Have
any
to be
other
engaged.
expert. Yeah.
Correct, sir.
Arun Mathur is asking any reference books on these geotechnical investigation. Well, there are a lot of books.
Lots of books are book क्या आजकल आप Google कर लें, ChatGPT कर लीजिए, you'll get ज्ञान at the touch of a button.
Not only that, our code IS 1892. If you see
Very
IS
good.
1892, now 2021 version, one can read that. It gives a lot of information on these tests, and there are cross references how these tests are conducted. I think that
Yes.
to start with IS 1892 is a good reference.
Very good reference, sir. Yes, absolutely.
Any studies on underream piles? These are now not permitted by IS code. So
Yeah.
let's not talk about underream piles. Currently, there are no codes available to evaluate rock fill. Does code committee planning for it? I think that is an unrelated question.
Yeah.
We can't answer that question whether Sanjay Gupta ji, we need higher factor of reliability with our data and absolutely. Vijit Kulkarni, I would request IS Tactic to arrange a couple of sessions from Saurabh ji on SSI, OCell testing and instrumentation of foundation. Yes, we will love that. Saurabh ji,
Absolutely,
please
sir.
come out with
Anytime.
some other webinar.
Done, sir.
Structural engineers want to learn from you. Then Mr.
Vice versa.
Suhash Khedkar, when you found more than double SPC based on new soil investigation technique, did you verify it by conventional plate load test? See, let me answer this question myself and then you can answer. See, the plate load test is totally outdated, misunderstood. Unfortunately, our codes still include plate load test. We should understand the limitation of the plate load test, that plate size is limited, maximum 0.75 or 1 meter. Its zone of influence is 1.5 times 1.5 meters. So when you are testing it, you are only testing 1 meter or 1.5 meter soil. For large foundations, for example, raft foundation or very large foundation, this is totally outdated. Test should not be done. We should rely on modern techniques like CPT test, or we should have shear parameters and evaluate bearing capacity. But I know people think that when we can test a pile, why can't we test a foundation?
Yes.
And to them, plate load seems to be the easiest test, but it is misguiding, and it has created a lot of problem. I have seen in my own career. I can share some other time. So, Mr. Saurabh, am I right? The code
Yeah,
of
absolutely.
the IS code 1888, in the first page itself gives the drawbacks of the plate load test.
Yes, correct.
So, in my opinion, except for shallow foundation, small size foundation, we should not do it at all. It is not required.
110%, sir. Plate load test should not be done. I think it's only good as a verification on site. आपको compaction control करना है, कुछ करना है, उसके लिए plate load test is fine. But to answer Mr. Swas's question, we haven't stopped at theoretical predictions. So we actually now, I mean, to be honest, we have we're probably the only company, we have an in-house R&D division, which is led by a very senior PhD from Purdue University. And we have actually taken this, we haven't taken these numbers lightly. We have talked with international consultants and professors, taken their opinion, or before we have made these recommendations. We have also on several of our sites, sir, we have not carried out plate load tests, but we have carried out footing load tests. So plate load test is done typically on 30 or 60 or 75 centimeter size plate. We have actually carried out full scale footing load tests on 2 meter by 2 meter size foundations at the foundation level. Again, it's not going to behave the same as the raft. It does have its limitation, but we have done it and we have tested it up to 1,000 tons. We got the load settlement curve from the footing load test. We have compared that with our theoretical load settlement behavior. And, that is how we have increased our confidence in our interpretations. Number one. Number two, what we are now waiting for is we are encouraging customers to do settlement monitoring of the raft. Because end of the day, actual project scenario, if the customer has the settlement data, these are so obvious, it's so simple, you can even have automatic total stations installed to collect the data during construction. End of the day, this is where the litmus test will come. Actual monitoring data compared with theoretical predictions. That is what is the need of the hour.
Okay, good. Thank you. Then another question by Mr. Venkata is in black cotton soil, any specific soil investigation you can suggest? Some soil improvement, etc.
No,
Any specific test to be done
perfect.
for black cotton soil?
Perfect. So black cotton soils, again, like liquefaction, we tend to panic. But black cotton soils, expansive soils are very common in the country and very easy to deal with. The only thing which you need to do is, especially in the active zone, make sure you have some good quality samples and do a lot of free soil index testing to understand the degree of, expansiveness of the soils and carry out good quality swelling pressure tests. So this is very important from a ground characterization point of view to actually understand the degree of expansiveness of the ground. So once you have this, then again you can go to solutions, whether it is proper drainage, whether it is improvement or adding CNS or MSN. So you can go, there's several improvement methods which are available as well, which you can adopt for your safe foundation practices.
Okay. The next question is from Mr. Nasir Islam. Rather, it's not a question. These are basically suggestions. Test results from advanced techniques need proper interpretation analysis, and I would request the panel members for detailed discussion and incorporation in codal provision so that pan-India awareness and reliable data-driven solutions are obtained. Also, calibration of such equipment shall be made available in India. Definitely, it's agreed.
Definitely.
And I wish our codes will change. And Mr. Saurabh is an active member of many committee, Mr. Sanjay Gupta, Dr. Ravi Sundaram. So I will request all of you change our outdated code IS 6403-8009 Part 1, Part 2. Luckily, 2
कोशिश कर रहे हैं.
Okay. Then Parveen Kumar asks, a good presentation. Happy to see everyone acknowledging the significance of geotechnical investigation. I hope it translates into practice. Then Nasir Islam, regarding liquefaction assessment, I would like to ask how a small seam of soil susceptible towards liquefaction can affect the structure vis-a-vis cost, because if such seams are encountered at deeper depths, it will result in huge variation in foundation design and cost thereon. So is
I
he
would
talking about some,
encourage, I
yeah,
would
small
encourage
seam? Yeah,
Nasir Saab, I will encourage you to get in touch with us directly. Small seams of liquefiable soil is very rare in practice, and could be a result of improper measurement. So please get in touch with us, and I would like to discuss this in detail with you. It could be just an odd SPT n value, जो मैं बोला ना स्प्रेडशीट में हम डाल के liquefaction conclude करते हैं. It could be one n value which is incorrect because some labor did it wrongly at site, basis on which we are concluding that there is a liquefaction seam. I have my doubts, and we should talk about this.
then another is Arif Junaid. What is meant by Packer test and how it will work? How it
So
works?
there is a code, sir. Packer test is a very simple test for measurement of in situ permeability of soil or rock. And I don't remember the number of the code, but if you search, there's a full-fledged IS code specifically on the Packer test, which I would encourage you to read.
Next question is from Mr. Parveen Kumar. As we are shifting towards in situ tests, are we overlooking the physical estimation of shear strength parameter of the soil by sampling method? It going to have any concept? Okay, this is a good question. In fact, I also want to ask same question. If our in situ tests are reliable enough, like CPT test, and give us all the parameters, you have shown us that we get most of the parameters required for design. Why we should do lab testing at all? Why lab testing is required? Because lab testing invariably will give you, parameters on lower side. The dilemma is, which one we choose. As per the
Right.
current practice, still people try to rely more on the lab testing. For example, phi
Yes.
value, when we calculate from SPT, it comes 40 degree, 45 degree. They still want to restrict to 30 degree or 35 degree.
Correct.
And nobody wants to increase it beyond 35 degree. And when we do a lab test, we end up with 30. So between 30 and 40, there's a vast difference.
Yes.
So, it's a very good question. Our codes also have to be modified because codes give you both options, but doesn't say
Yes.
anything. which one to choose.
उसमें एक
So,
तीसरा फैक्टर आता है सर, which value to use in the analysis. The phi
yes.
is not the same as delta, which is supposed to be used for pile capacities.
Mm.
So the many things, but I think it is a fantastic question, and I think something which we are also working with. So our approach to this is the following, sir. So we have been doing advanced testing now for 4 or 5 years. So we started around COVID, is when we introduced a lot of these things in India in a big way. So initially we did a lot of projects where we did both. We did boros and CPT, and I think it is a matter of CPTs is not new, by the way. So in India it is new, but the technology is from 1960s. So worldwide, when I started my career 20 years ago, at that time also people were doing CPT-based investigations, but they took many years to develop that confidence in the finding of the CPT and to understand the test results and to understand how to interpret the test results. So I think here it is better to have a step-by-step process. Again, in areas where the geology is not very well known, it is always better to carry out boros and CPTs, do lab testing, get the CPT-based parameters, cross-correlate, mostly as to increase your confidence in the results. And as we move forward, and as already, our confidence is increased in many parts of North India, and many projects, say, which are not warehouse projects and factory projects in areas where the geology is known to us, where we are able to now confidently do only CPTs as well and give soil reports.
Okay,
So it's a
good.
process.
Yeah, I think we are moving in that direction, but it will take time. Okay,
Yes.
next question is from Mr. Mandala. How can we trust the sleeve friction and tip resistance measurement given that the CPT cone is pushed into the soil without replacing the volume it displaces? That is creating a void as the cone and rods displace the soil rather than removing it. Maybe you can answer this question. He says, how can we
Yes.
trust the sleeve friction and resistance measurement? And he says there is some reason he has given.
I'm going to answer. I think it's a good question. It's a thought-provoking question as well. I want to answer the question with a question: is how can we trust the SPT values which we get when we actually remove the overburden, we change the in situ stress conditions, and then we do a test in changed stress conditions. So how can we test that? How can we trust those numbers?
Yeah.
So I think I would leave it there. It becomes very theoretical. Again, the background is, there's a lot of research which has been done on CPTs, pressure meters, dilatometers, SPTs. Actually going into, looking into the detail of cavity expansion and behavior of the soils, and all kinds of, deep, theoretical research has been done, which I'm not an expert on.
Then, Mr. Saurabh, basically CP test represents the resistance we encountered in terms of slip friction and tip resistance, isn't it?
Yes, sir.
So I don't think it has anything to do with soil displacement. The purpose is to measure the resistance, isn't it?
Correct. Yes, sir. Yes, sir. Absolutely. And it doesn't displace the soil that much either. You actually push through the soil, and the cone is very small. It's a tiny cone, 2.5 inches.
And so much of research has been done. So these are now standardized.
Very much so, yes.
There's a question from Mr. Ritu. What is best ground improvement solution for silty sand strata with 90% silt with liquefaction up to 10 meter? No.
I'm very careful not to answer these questions, Mr. Ritu.
Yes.
I would highly urge you to get in touch with us so we talk about details. I don't like to give knee-jerk responses. It can be very dangerous and misleading for you.
And what is the best method to estimate shear strength in loose sandy soil where CP test data inconclusive?
Very
Well,
good
inconclusive.
question. Inconclusive. Good
What
question.
is the best method to estimate shear strength in loose sandy strata where CPT data is inconclusive? What do you mean by inconclusive?
I'll tell you, sir. I don't know what he means by inconclusive. I think CPT is very good if you're able to push deep enough. I think CPT is fantastic for loose sandy soils, because what happens is in borehole investigations, if you have loose sandy soils, and I presume this might be below the water table, really all we are left with is SPT, because collecting good quality samples in loose sandy soils below water table is next to impossible, right? You simply can't do it. It's very hard. So CPT is, I think, a good option. That said, I will give you another option, is change your sampling method. So in loose sandy soils, typically, we should not go for Shelby tubes or open tube samplers. These days, many good samplers are available. Like we use Mazier samplers. With a hydraulic drilling rig, we use Mazier samplers, which are like a triple tube core barrel, right? And it's got a piston system. So Mazier samplers, we are able to actually, it's not easy, but we are able to extract fairly good quality, almost intact sandy samples as well for lab testing. And as I said, we have done a couple of critical projects where we have encountered this formation, and we've taken up the challenge. And with proper investigations, we have managed to extract good quality samples for lab testing as well. That said, always, I think, greater emphasis and reliability is on in situ testing. So whatever we got from the lab, we checked it against what we got in situ from CPTs and pressure meters.
Okay. So Mr. Klish is asking another interesting question. In liquefaction susceptibility assessment, N60 values used, which account for energy correction and overburden correction. Whether dilatancy correction is also required to be done for this corrected N60 value.
Great. So I think there are 5 corrections, and I don't remember this verbatim, but there are 5 corrections which you have to apply when you check for liquefaction, and I believe dilatancy is not one of them. I also want to point out that the code currently, which is based on the NCR summary report, I'll just have said, is gives some factors for C sub E. So the C sub E, which is energy correction factor, the code gives a table with some standard numbers. कि automatic trip hammer है तो 1.3, manual है तो ये है, rope cat head है तो ये है. I do highly encourage is if you are suspecting that there is liquefaction at the site, and this is where value engineering comes. Let's not just plug in the standard factors given in that table. That table is based essentially on lots of SPT energy measurements done in North America over many years on their machines, right? And based on their experience. But the SPT arrangements we are using in India are completely different. So the best way to do it is just carry out SPT energy measurement for your site and actually correct your N values to N60 values before deploying those numbers in liquefaction analysis.
Another, doubt is that internationally dilatancy correction is not applied to SPT values. It's
Correct.
always N60. So
Correct.
why dilatancy correction is required, and why, as per our code, why it should be applied?
I honestly, sir, don't know how to answer that.
Okay.
I think it's just practice. I haven't gone into where this came from. I think it's just been part of our practice. It's come from the UK actually.
But whether we see Astro code or Euro code, no code talks about dilatancy correction. I don't know where from
Yes.
it has come. And
I am
okay,
not the best person to answer that. I don't have an answer to that, but I'll get back to you. I'll find out.
okay. Because in IS 1893, there is a soil classification. Soft soil. Now, of course, code is changing, and now soil classification will depend on seismic wave velocity. But in the earlier code, old code, based on SPT only, soil classification has been given: soft, medium, hard,
Correct.
and there it relates to N value. Value in
Yes.
IS 1893 tells us it is to be corrected only for overburden pressure.
Correct.
And I mean, it talks only
So
overburden. But
it
many
was very
people,
confusing. That table
very
was very confusing. वो समझ ही नहीं आया मेरे को आज तक how
and
to
many
use that
people
table.
want to apply dilatancy also. So,
Yes.
but being a dynamic case, seismic is a dynamic case.
Yes.
Where to my best of my understanding, dilatancy is because of the, when you are doing SPT test, you are doing an instantaneous test, and because
Correct.
of core pressure, dilatancy is there. But
Correct.
so in a seismic case, I mean, this should not be applied. Probably that's what code is saying, but we don't
Yes.
have much clarification on that. Okay. Then, Mr. Parveen Kumar, please comment on using artificial intelligence in situ testing and machine learning for site vectorization using the characters. A lot of questions.
Sorry, sir.
So,
I don't understand this very well yet, but I know there's a lot of research being done on AI and ML in geotechnical practices. In fact, IITs are doing a very good job. A lot of students are working on this, and maybe sometime in the future, I don't know, near or far future, we'll all be replaced by ML. Until then, we have to try our best.
okay, there's another question. Can CPT be made for granular or stony soil? Mr. Saurabh explained that in gravelly and bouldery strata, CPT cannot be done. That's what
Correct.
you said. Then
Yeah,
somebody
but if
wants
it is
your
a
contact
loose,
number.
if it's a loose gravel deposit, then definitely yes, you can.
Please share details of Mr. Saurabh Gupta as he mentioned to contact regarding my question. I think
Right.
his contact details are available.
Correct.
Maybe on the first sheet, he has given his phone number as well as email. So the flyer, I think flyer gives all the information.
Yeah. Flyer, and it's yes. I have put it in the chat box also. You can note down
Yeah.
99108 or drop us an email.
So I will, stop the question answer session because of lack of time. And in chat box, there are 37 people who have, written, and there are a lot of questions there also. So I would
Right.
request them to write to Mr. Saurabh Gupta separately. I am sure he will answer, because if I start taking up that question, it will take 1 more hour. But
Yes.
most of them are complimenting you on your excellent presentation. And as they say, dil mange more. So maybe we will have one or two more presentation from your side.
Absolutely.
And yeah, so thank you very much. I think with this, we close the session. And I profusely
Yes.
thank Mr. Saurabh Gupta for his excellent presentation. And not only that, very patiently, he has answered all the questions, and people are not tired of asking questions. And there has been very good participation from the participant, and there are people who just don't want to leave. So thank you very much, Mr. Saurabh, and thank you all the participants, because without you, this webinar would not have been successful. And on his behalf, Mr. Saurabh Gupta's behalf, maybe I can assure you that we will have another session. Thank you very much. Thank you very
Thank
much.
you so much, Aujaz sir. Thank you.
Thank you.
Namaskar.
Thank you. Good night.
Thank you. Good night.